Greetings one and all, and welcome to this class. Very sorry that, very sorry that we were unable to meet physically. We were unable to meet live, I should say, because of course of the connectivity issues. But we're still moving on. And so hopefully as you watch this lesson, you understand the things that are being said. Please take good, diligent notes. Please take good, diligent notes and send them to me when you're done to let me know that you understand what's going on and stuff like that. All right, so we begin, and so let's continue, or let's move on with the lesson. So the last time we were here, we were talking about interval notation, all right, and inequality notation. And we said that the open bracket, all right, this open bracket here means that we do not include -7, whereas this closed bracket here means that we do include 9, all right? So we do not include -7, but we do include 9, all right? And if we were to draw that graphically, right, in one dimension, right, if we were to draw it on the x-axis, right, we would have -7, but we have an open parentheses, and that means that we do not include 7, all right, but we include everything in the middle, so everything in the middle is included, so let's make a good note of that. Everything in the middle is included, all right. So this is basically saying what are the numbers that are between -7 and 9. So we are going to include all these numbers here, and we also include this endpoint, the right endpoint, which is 9, okay? And this square bracket or this rectangular bracket represents the fact that, hey, we are going to include 9. So this is one way to represent it in interval notation. Another way to represent it, the same thing, the same set of numbers, is inequality notation. And for inequality notation, this is saying that x is between -7 and 9, but we include the 9, okay? So we do not include 7, but we include the 9. So we're referring to all the numbers in between -7 and 9, including, right, 9 itself, all right? So that's that's interval notation and inequality notation. That's one way, all right? So far we've learned, right? So far we've learned what it means when we have two brackets open and we have two numbers. Let's say our numbers, we represent our numbers using A and B. We know that this means, hey, we want all the numbers in between, right, A and B, but we do not include the endpoints A and B. And here, if we are open on the A but closed on the B, that means, hey, we want all the numbers in between A and B, but we include B, all right? And if we have this part is closed, and if we have this means that, so if we're open on the B but closed on the A, that means, hey, we want all the numbers that are between A and B, but we include A, but we do not include B, okay? So those are our options that we've seen so far. We've seen where we have both sides are open, all right? That means we do not include A and we do not include B, but we include everything in between. We have seen where we have A open, so this part is open, but this part is closed, so that means, hey, all the numbers in between A and B, but we include B, but we do not include A. And finally, for this one, this is saying all the numbers in between A and B, we include A, but we do not include B. Okay, so that's how we read it. Now we're not done. There is another type of inequality notation, or there's another type of example to this. So notice we consider when there's both open, one closed, one closed, one open. But what if we have where they are both closed? All right. What if we have something where they are both closed? How would that be? What would that look like? But if they're both closed, we're gonna have something looking like. So let's separate our separate our board here. Okay, separate our board, and so we're gonna put this side interval notation. Interval notation. Interval notation. And on the other side, we're gonna have inequality notation. Inequality notation. So on one side we have interval notation, on the other side we have inequality notation, and we are considering the fact or the instance where both are closed. So what if we are closed on the A, and let's say we are also closed on B? All right, so closed on the A and closed on B. What does that mean? Well, right, if we go here, right, this means open on 7 means that we do not include 7. Close on 9 means that we include 9. So if both are closed, right, if both are closed, that means that we what? We do, right? So let me not write that too far down. What that means is that we do include, so we do include, so we include both endpoints. So we do include A, and we do include B. Now you may be wondering, what does A mean? What does B mean? Well, A represents any number and B represents any number. Okay, so A and B are numbers. So here we are saying, hey, include A and include B. Now, how would that look in inequality notation? Well, that would be X is less than or equal to B, and we have less than or equal to A. So this, we read this as A is less than or equal to X, and X is less than or equal to B. So in both instances, we have the line at the bottom. We have the line at the bottom signifying that we include A and we include B. All right. So how would we read this? We say we do include A, and we do include B. Okay. Now, how would that look graphically? How would that look graphically? Well, graphically it would look like this. So we have our x-axis, all right, and here we have A, and here we have B. Okay. Now on both instances, or on both sides, all right, we are going to have the square bracket. So this is going to be the square bracket right here. All right, the square bracket, and here we have the square bracket again. All right, the square bracket again. All right, so that means on both ends we include A and we include B. So we include both endpoints, and so on both ends we're gonna have the square brackets. So this set basically is referring to all the numbers that are in between A and B, right? All the numbers that are in between A and B, but we also include the endpoints. We also include A and B. So all the numbers in between A and B, but we also include A and B themselves. All right, next up is the second one. So how do we represent this in our inequality version? So we would draw a line, our x-axis. This is in one dimension. We draw the line. All right, and we would put our A and B. Remember, A and B they just represent any number. All right, so this works for any number that we have. So A is the smaller number, B is the bigger number. And so, all right, so how would we represent it in this form? What we do is we place a circle above A, alright, and we place a circle above B, but since we include A and we include B, we're going to shade it all in. So we include A, alright, so we include A, alright, so we include A, alright, and then we're also going to include B. So the shaded in, right, the shading in tells us that we include that number, and the next shaded part means that we also include this number as well. So we include our endpoints. So all the numbers in between A and B, but also A and B, the endpoints are included as well. Okay, so we are shading in right now. Okay, awesome. Now what we're going to do is we're going to draw a line in between. Alright, so we're going to draw a line in between them, signifying that we include these numbers in between. Alright, so that is how we do it, and that is the last one. That's the last type. So remember the types? The type wherein both are closed, the type wherein one is closed, one is open, one is open, one is closed, and a type wherein both are closed. Okay, and you have to understand what they mean and have an understanding of what's happening there. Okay, so let's consider an example. All right, so let's consider an example. Let's increase the number of slides that we have here. We're gonna consider an example. Okay, all right, so we're gonna split the screen into two, where we have interval notation and inequality notation. Please take good notes. All right, don't just watch idly, take good notes. Make sure that you're taking good notes and send them to me once you're done. So interval notation and inequality notation. So interval notation and inequality notation. So interval notation and inequality notation. Okay, so what do we do here? Well, here we are going to, let's say we have, say for example, we have -2, comma, and we have, say 5. All right. And what that means is that we're going to consider all the numbers in between -2 and 5. But here we what? We include, so we are going to include -5, and we include -2, and we include +5. All right. So we include -2 and we include +5. Now how are we going to write this exact same thing in inequality notation? Well, what that means is that x is going to be in between 5 and -2, but remember now we include -2 and we include 5. Okay, so all the numbers in between -2 and +5. So again, we include -2 and we include 5. All right. Okay, awesome. So now let's draw the graph of this. And so we're gonna draw it on the x-axis. All right. We're gonna place this -2 here. Let's put a 0 so that we can get our bearings, and we're gonna put 5. All right. Okay. Now how are we gonna do this in interval notation? Well, remember square brackets. All right, square brackets. So this is gonna be -2. All right, so square brackets here. So we include -2 and we include positive 5. Alright, okay, and remember we are considering, or we're looking at, all the numbers that are in between, negative 2 and positive 5, but we also include the endpoints as well. Okay, so this is how we would graphically represent this inequality, this interval notation. Right? So this is how we represent this on the x-axis. Alright, so let's do another one. Excuse me. Alright, so again we draw the x-axis and we are going to label it properly. So we're going to put the 0 in the middle. Alright, the 0 is in the middle. We're going to put the negative 2 here. Okay. We're going to put positive 5 all the way here. And what we're going to do is we are going to put a circle above the negative 2. How do we know that? Because we're dealing with negative 2 here. And we're going to put a circle above 5 because we're dealing with 5. Then we are going to shade it in. Shade it all in. So we're going to shade it all in. Why do we shade it? Well, we shade it because we are dealing with, because it says that it's less than or equal to, and we said that we include negative 2, so that's why we shade it. Alright, so we're going to shade it all in. Alright, and then here we're going to shade it as well, so we shade the positive 5. Alright, so we shade the negative 2 and we shade the positive 5. Next up, we're going to put a line in between. Alright, a line in between, telling us that we include all the numbers in between negative 2 and positive 5, and we also include the endpoints negative 2 and 5. Okay, so hopefully this makes sense to you. Hopefully you're getting it, right? So what are we doing? This is interval notation. This is telling us that we include negative 2, we include positive 5, but we also are talking about all the numbers that are in between this. So 0 is in between this, negative 1 is here, 4 is between negative 2 and 5, 3 is between negative 2 and 5. Alright, so we include all the numbers that are in between, right? But we also include the endpoints, negative 2 itself and positive 5. Alright, so bear that in mind. Next up, we have this side, which means the same thing, right? So here we have negative 2 is less than or equal to x. So that means that x is going to be greater than or equal to negative 2. So x could be any number. It could be bigger than negative 2. So 0 is bigger than negative 2. 4 is bigger than negative 2. They could be bigger than negative 2, but they must be less than 5 though. Less than or equal to 5. So, 4 is less than 5, 3 is less than 5. And 5 is equal to 5, and that could be included. Okay, so this is one good example. Let's consider another one. Alright, so we're going to separate our screen again into two sides. Interval notation, so two sides, interval notation, and also inequality notation. So interval notation and inequality notation. Alright, so let's consider an example looking like this. Let's say that we have it on, let's do this side first. So instead of doing the interval notation side, let's do the inequality side. So let's say that we have x is less than or equal to 9, and x is greater than or equal to negative 6. Alright, so how would we represent that in interval notation. All right. So remember, this is saying that, hey, x is going to be between -6 and 9, but we include the -6, all right, and we also include the 9. So in interval notation, what that is, well, that's simply, well, we include -6 and we include 9, all right. Okay, so that's how we would write this inequality in interval notation, right? So we include the -6 and we include the +9. Okay, awesome. So let's write it down as like so. So this is going to be we include -6 and we include +9. We include, same thing, we include -6 and we include +9. Okay, great. Now, how do we represent that? How do we represent that on the graph? Well, let's begin with the interval notation side. So it's going to be on the interval notation side. Sorry, we're going to begin with the inequality notation side. So on this side, we draw the x-axis. We have the 0 in the middle. We want -6. Let's say that's there. That's there. +9. Let's say that's there. And what we're gonna do, since we have it's x is greater than or equal to 6, we are going to place a big circle above +6, and we're gonna place a big circle above +9. Now, in both cases, we're gonna shade, right? We're gonna shade in the endpoints. So we're gonna shade in the endpoints. So we're gonna shade in -6, right? So we shaded in -6. We're gonna shade in -6. All right, and we're gonna shade in +9. So -6 is shaded in. That's great. And then +9, we're shaded in that right now. All right. So -6 and +9. The next thing we're gonna do is we're going to put a line in between them. All right, like so. Great. And so that's how we do it. All right, next up, we are going to do the same thing on interval notation, but we're going to do it in a different way, like how we did the previous one. All right. And so we're going to have 0 in the middle, -6 somewhere here. All right. And +9 right here. All right, awesome. Okay, great. So what we're going to do is we're going to place a square bracket here. So we're going to place a square bracket on this end. And on this end, we're going to place another square bracket, symbolizing or letting us know that, hey, we include -6, and hey, we include +9. Now, we are considering all the numbers that are in between, right? In between -6 and +9. All the numbers that are in between -6 and +9. All right? In between, all the numbers that are in between -6 and +9, but we also include the endpoints. Oopsies. Sorry, I should not allow that green to go over. So let me do it again. So this is going to be, we include -6 and we include all the numbers in between as well. Right? So 0 is included, 1 is included, 2 is included, 3 is included, 4 is included, 5 is included, 6 is included, 7 is included, 8 is included, 9 is included, everything is included. So include all the numbers in between and also the endpoints. Alright? A nice happily ever after. Everyone is included in this one. Okay, so there you have it. Interval notation and inequality notation. Right? Considering where we have closed intervals, both of them are closed. Alright? Okay, we can do one more of these. Alright, so let's do one more of these and then we'll go on into another set of exercises. Okay, so let's split the screen again. Sorry. So we're gonna put on one side, we're gonna put in interval notation. So on one side, we're gonna put interval notation. So interval notation. So interval notation. And on the other side, we have inequality notation. Remember that as you are watching, please take good notes. If you have any questions on what is being discussed, you can always send me a message. Okay? You can send me a message and contact me so that I can explain to you any issues that you have. Okay? So let's consider this example. So in this example, let's say that we can start off in the interval notation side. So let's say we have -3. Alright? So let's say we have -3. And let's say that on the positive side we have, say, +4. Okay, so -3 and +4. So how do we represent that in inequality notation? Well, what that means is that we want all the numbers in between, right, 4 and -3. So we are considering all the numbers that are in between 4 and -3, but we include -3 and we also include +4. So written in words, we say we include all the numbers in between 3 and 4, but we also, we include all the numbers in between -3 and +4, but we do include -3 and we do include +4. Next up, we write the same thing. We do include -3 and we do include +4. Alright, awesome. Okay, so how are we going to represent this on the number line? So let's do this. So this is going to be, we're going to draw our x-axis. Alright, so draw our x-axis. We're going to place a 0 in the middle. Alright, then we place -3 somewhere here. And you want to eyeball it, okay? You want to give it a nice eyeball. You want to basically give a good estimation or approximation of it. And then if this is -3 here, obviously, and we're dealing with +4, obviously we're not going to do the same exact length. We're going to push it a little bit more. So somewhere here. So this is +4. So you want to make sure it looks realistic. Okay. Okay, so -3, we include -3, so we're going to use a square brackets. So remember, we include -3. -3 is included. Alright, we include -3, and we also include +4. +4 is included. So we include -3 and we include positive 4. Alright? Alright. Please forgive the background noise if you hear it, or the background talk. I am not home alone, so please forgive me. Alright. Okay, so we have 0 here, and we are going to put the endpoints. The endpoints have to be in the diagram. So it's going to be -3. And if this is -3, positive 4 would be somewhere here. And so we include -3. And so we're going to use a circle, a big circle. Alright. A big circle on both ends. But because we include it, we're going to shade in those circles. Alright, sorry. So let's do it properly. So we're going to shade it all in. Shade it all in. Shade it all in. Alright. Shade it all in. Alright, next. Next, we are going to shade in the positive 4. Alright, we're going to shade in the positive 4. We're going to shade in the positive 4. We're going to shade in the positive 4. Alright, next up, we're going to draw a line in between. And we're saying by this line that, hey, we include all the numbers in between. So all the numbers in between 3 and 4, but we also want to include the endpoints -3 and positive 4. Again, I should say we include the endpoints -3 and positive 4, and all the numbers in between -3 and positive 4. Similarly, when we go on this side, we include all the numbers in between -3 and positive 4. Alright, we include all the numbers in between -3 and positive 4. All the numbers here. Okay. Alright, awesome. So that was 3 good examples. 3 good examples. So hopefully the idea is clear in your mind of when we have interval notation, alright, when it's with closed intervals, and inequality notation with closed intervals. Alright, awesome. So hopefully that idea is cemented and you have a good grasp on it in some sense. Alright, so let's move on. Let's consider these examples, or these this exercise sheet. This is a very important one. It says choose the correct interval that best describes each inequality. Alright? Choose the correct interval that best describes each inequality. Okay? So here we have the inequality, and we read this in a specific way. Okay? How do we read it? Okay? How do we read that? Well, we read it as, so let's circle this. How do we read it? We read it as, alright, as x, okay, x is less than, so that's strictly less than 11. So x is less than positive 11. Okay, so that's how we read that. We read that as x is less than positive 11. So that's what this is saying. X is less than positive 11. And they're saying which interval notation will correspond with this. Is it going to be A? Right? Is it going to be B? Right? Is it going to be C, or is it going to be D? All right. So which one is it? So let's begin by considering A, all right, and see if A matches what this is saying. So we're gonna try all of them. We're gonna see which one is the correct one. All right. Okay, so let's move this. All right, should be good. So we have these different options, right? These are different options, and remember, we're trying to represent. X is less than 11. X is strictly less than 11. So which one of these works? So let's try this one. What is it saying? Well, certainly this is saying that we include positive 11. All right, and here we are open on positive infinity. And the reason why we do that is because you cannot include positive infinity. The reason why you cannot include positive infinity, and by the way, let me make that clear. This sign, this symbol, is the infinity symbol, and when you see it by itself, or when you see a plus sign in front of it, we say that that is positive infinity, right? That's positive infinity. Positive infinity. And when you see it with a negative sign in front of it, that means we're dealing with negative infinity. Negative infinity. And so the idea here is that you can never reach positive infinity. Okay? So what do we mean? Okay, let's consider. So let's say, think about the biggest number you could think about in the world. 1 million. There's something bigger than that. So if you say 1 million, someone could say 1 billion, someone could say 1 trillion, and then someone could say 1 zillion. Like, you could never reach, sorry, someone could say 1 zillion. You could never reach positive infinity, right? You can never close off. There's no such thing as the biggest number. There is no biggest number, right? Because if you find the biggest number, let's say if we find the biggest number and we add 1 to it, that other number becomes bigger than that biggest number. And so there's no such thing as the biggest number. The numbers just keep on increasing. So that's why we never could include positive infinity. We always leave it as an open interval. That's very important. For positive infinity, we always leave that as an open interval. We never could include that. All right, because if you whenever you are including a number, you're saying, okay, this is a number, we got it. We could include it, right? But we can't include positive infinity, because positive infinity is not a destination. It's not a place, right? You cannot ever arrive to it. All right, or I should say, you cannot arrive to the biggest number. All right, we just continue on increasing. Just think of positive infinity as an idea that basically means continuing on. That's what it basically is telling us. So in simple terms, what this notation is saying to us, all right, what A is saying to us. So A is saying in words, right? A is saying, let's look at A again. A is saying, hey, start at 11, because we could start at 11. Start at 11 and go on, continue on, and on, and on, and on, and on, until you reach positive infinity. And I put that in quotation. Basically, continue on and on and on and on forever and ever and ever. That's what this basically is saying, all right, in layman's terms. So this is saying, if we were to put it in words, this is saying, if we were to put this in words, it's saying, hey, start at 11, all right? Start at 11 and continue on forever. Alright? So start at 11 and continue on forever. So that's what this is saying. Listen, start at 11 and then continue on forever. Now, how would we, write that or draw that, graphically? Well, it's going to be something like this. This is, if we put 0 here and we put 11 here, this is saying, hey, listen to me carefully. Start at 11. So start at 11. Start right here at 11. All right. And then where are we going to go after 11? Continue on, go on, get bigger and bigger and bigger and bigger and bigger and never stop. So start at 11 and continue on forever and ever and ever, or until you reach, I put it in quotation, until you reach positive infinity. Which we can't really reach positive infinity. But we only say that to mean we continue on forever and ever and ever. So start at 11 and continue on until positive infinity. All right, or continue on forever and ever and ever. So, okay. So that's what this notation is, right? In a graph, right? Now how would we write this in inequality notation though? So let's see. So we start at 11. Let's look at all these numbers, right? That would be inside this this set. So, well, 12 is gonna be here. So 11 is gonna be here. 12 is gonna be here. 13 is gonna be here. 14, 15, 16. All these big numbers, 17, 18, 2020, 2022, 1 million, it's bigger, right? So that means that x is bigger than 11, right? Because we start at 11 and we continue on until positive infinity. So if we were to write this in terms of inequality notation, this would mean, or we would say that x, in order for x to satisfy this, or to be in the set, or in order for x to satisfy this inequality, x must be bigger than 11. Excuse me. So this inequality, right, represents this graph and also this interval notation. The interval notation, which is 11 and continue on to positive infinity. These two are saying the same thing, right? So this is saying x is bigger than 11. And this is saying the same thing. We start at 11 and we continue on to positive infinity, getting bigger and bigger and bigger. And so these two are saying the same thing, all right? X is greater than 11, and we start at 11 and we go on to positive infinity. So is that right for this one? This one is saying, hey, x is less than 11. X is less than 11. But A is saying, hey, no. X is greater than 11. So definitely we know that A cannot be our answer, right? A cannot be our answer. We cannot have A here, right? That's not right. Because A is saying x is greater than 11, but we want x is less than 11. All right, so bear that in mind. Okay, so let us start at C and see if let's do C and see if C works for us. Remember, we're trying to find one that represents x is less than 11. And so let's start at C and see if that works. So we're going to start at C and see if that works. That's cool. We're going to start at C and see if that works. Pretty cool, right? Alright, so let's begin, or let's continue rather. Alright, so what is it saying to us? Well, it is saying, hey, notice that we are open on the negative infinity. We never close on a negative infinity or on a positive infinity. The reason why we don't close on a negative infinity is for the same reason why we don't close on a positive infinity. Because you cannot include negative infinity, right? How can you include negative infinity? Negative infinity, okay, find negative infinity, right? How will you find negative infinity? you cannot negative infinity is not like a number you could like touch, right? Negative infinity just refers to this idea that, hey, we get smaller and smaller and smaller and smaller and smaller. Like there's no such thing as the smallest number, right? There's no such thing as the biggest number, and there's no such thing as the smallest number, right? Pretty interesting idea, right? We get smaller and smaller and smaller and smaller and smaller and smaller. You say, okay, I could find the smallest number. Okay, I dare you, find it. You say, okay, Mr. Petit, I got the smallest number. And then, let's say you say that the smallest number is negative 2,000. Let's say that you say that's the smallest number, Mr. Petit. Well, I could find a number smaller than that. We can say negative 3,000, right? And if you say, okay, Mr. Petit, okay, that definitely have to be the smallest number. No, I could find a smaller number than that. Negative 4,000. That's smaller than negative 3,000, right? So we could always get smaller. And so negative infinity is not a place. Negative infinity is not a location. Negative infinity is not a number. It's an idea, right? That tells us that, hey, listen, we are going to get smaller and smaller and smaller and smaller. That's why we could never include negative infinity, right? We always leave it open. All right, so this is saying, hey, listen, start at negative infinity if that's possible, insofar as possible, right? Think about it later. So start at negative infinity, right? And then get increasingly large until you get to negative 11. So let's draw that visually, okay? So we're gonna start at negative infinity and increase it and get increasingly large. All right, so how would we draw that graphically? So we start at negative infinity. Now we know that negative infinity is not a place. We in truth cannot really start at negative infinity, but we're just saying that, hey, all of the numbers that are small, the small numbers, all the numbers that are less than negative 11 is included in this set. All right. So we start at negative infinity, or we begin at very small numbers, small numbers, and we know we cannot ever stop at the very small numbers. But let's say that we start there, even though we cannot really start there because we can never really find the smallest number. But just think about all the numbers that are very small. So in quotations, we start at negative infinity, and we go on and on and on. We get bigger and bigger and bigger, bigger and bigger and bigger until we arrive at negative 11. All right, and let's say that 0 is here. Now we are going to start at negative infinity and go on and on until we reach the negative 11. Now here we are going to, they say, include negative 11, and so we could include negative 11, and we include it. All right, so basically you can also think about it in reverse. We start at negative 11 and we get smaller and 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 smaller until we arrive at negative infinity, quote. But we really just getting smaller and smaller and smaller because you can never really arrive at negative infinity. Okay, and so this is what this is saying. All right, we start at negative 11 and we get smaller and smaller and smaller and smaller and smaller and smaller and smaller. So how would we represent this in inequality notation? Well, okay, all of these numbers here are going to be less than negative 11. So if we take a number, call it x, we know that whatever number that is in this set is going to be less than negative 11. All right, so all these numbers inside the set represented here in red, it's going to be less than negative 11. Less than negative 11. Okay, but we want it to be our inequality. We want it to be x is less than 11, not negative 11. And so this one wouldn't work either. C wouldn't work. Okay, so C would not work for us. Nope, unfortunately C cannot work. Okay, So let us say, let's try D. See if D gives us anything. Let's try D and let's see if it works. So first we need to get an understanding of what this is actually trying to say to us. What is D trying to say? You know, what does it mean in words? Okay, so for D, this is saying, hey, listen, start at -11 and get increasingly large all the way to positive infinity. All right, so start at -11 and get increasingly large, and listen, never stop. Again, we do not put a close sign on or close interval or square bracket on the positive infinity because we could never arrive at positive infinity because, you know, like we discussed before, you know, there's no such thing as the smallest number. Sorry, there's no such thing as the biggest number. We always could find another number bigger, right? So there's no such thing as the biggest number. Numbers continually increase, right? That's amazing. That's an amazing idea, right? Wow. And so we have -11 all the way up to positive infinity. So we start at -11 and be going increasingly large all the way up to positive infinity. All the way, keep on getting bigger and bigger. And so how would we represent that on a graph? So we have our x-axis. Okay. We are going to, we have 0 here. And we have -11 here. And again, we are going to start at -11. Okay, so we're going to start at -11. We include -11, by the way. And then we're going to get increasingly large. All right, increasingly large. All right, all the way to positive infinity. Basically saying that we never stop. And so the idea here is that, well, if we look at the numbers that are going to be inside here, these numbers, call it x, call a number in here x. Let's say we take a number with there x. Well, a number in here inside this, you know, set, right, inside this interval here, is definitely going to be greater than, right? Definitely going to be greater than, -11. Certainly going to be greater than -11. But also could be equal to -11 too. And so x is going to be greater than or equal to -11. All right. So for this one, we have the inequality x is greater than or equal to -11. Okay. X is greater than or equal to -11. All right. So, but that's not what we want. Hey, we want it to be x is less than 11. Now, in doing this, I realized that the inequality I gave you for this and this is not correct. Let's fix it. The inequality for this one, remember for this one, this means that, hey, we start at negative infinity and we get increasingly bigger until we get to -11. So the correct inequality for this one, and please forgive me for the mistake, it's supposed to be x is going to be greater than, no, if it's in between there, no, x is going to be less than, sorry, x is going to be less than or equal to, that's what I forgot to put, or equal to -11. Okay, so that's the associated inequality. So for interval notation for this one, we know that, hey, this is saying, hey, we start at -11 and we get bigger and bigger. All right, and so any number in here is going to be bigger than -11 or equal to -11. This one is opposite. This is saying, hey, we start at negative infinity, we get increasingly bigger to -11, or you could say, you know, think of it as we start at -11 and we get smaller. we get smaller. We get smaller. So x is going to be less than or equal to negative 11. I forgot to put the equal to. And then for this one, I also made a mistake because we also supposed to put or equal to. Notice that let's consider it. Well, we start at 11 and we get bigger. So x definitely going to be greater than 11. Right? That's true. X is going to be greater than 11 because, well, inside there we have stuff like 25, 26, stuff like that. But it's also going to be equal to, right? So that's what I'm supposed to put as well. X is greater than or equal to 11. So, clearly, this inequality is not going to work, right? This inequality is not going to work. X is greater than or equal to negative 11. That's not that. We want x is less than 11. This one is not going to work because its x is less than or equal to 11. So that's not going to work. This one is not going to work because its x is greater than or equal to negative 11. That's not going to work. So let's try B. And right now you're probably smiling because you're like, okay, definitely B is the answer. But let's try. Let's see if it's right. Let's verify, right? Let's verify it. Okay. So please forgive me again for the mistakes I made for this one. It's supposed to have the equal to symbol as well. All right, that's what I forgot on the other one. So please make those changes. All right, so let's consider this one. So here, right here, we have negative infinity. Okay, negative infinity is good. And we have 11. And so what this is saying is that, hey, listen, start at 11 and get smaller and smaller and smaller and smaller and smaller and smaller and smaller. But then we cannot really start 11 because this is open. So we do not include 11. All right. So this is saying start at 11, but don't really include 11. All right. Don't include 11. But just use 11 as a marker, but don't include it. And then get increasingly smaller till you reach to negative infinity. And of course, we cannot arrive at negative infinity because, there's no smallest number. But start at 11 and get smaller, and start at 11 and get smaller and smaller and smaller. So how would that look graphically? Graphically, that would look like this. So we are going to start at 11. All right. We do not include 11, so we're going to use a open bracket to say, hey, we do not include 11. All right, and then we're going to get increasingly smaller. Going to get increasingly smaller until we arrive at negative infinity. And so let's think about it. Any number in here is going to be less than 11. Think about it. Any number in here. So we start at 11, we get smaller and smaller and smaller and smaller. So numbers like, 5, numbers like, 4, sorry, positive 4. Numbers like 3. All right, numbers like 3, 2, all right, 1. All these numbers are less than, right? They are less than 11. So x, or any of these numbers, is going to be less than 11. So that's the associated inequality. X is less than 11. Okay, and that's exactly the one that we want. X is less than 11. So we're looking at all the numbers that are less than 11, and we do not include 11. And so this here is the correct answer. Okay. Now there's an easy way we could identify the answer, and I could tell you there's a very easy way that we could know immediately what the answer was. And let me tell you, notice that here this is a script inequality. So we don't have a line at the bottom. So that means in this case we do not include 11. So let's look for this option. Here they include 11. So we already know that this wouldn't work because we did not include 11 here. This was script because this means that we do not include 11. But here they include 11, so that definitely ain't gonna work. Here they don't even have 11. They just have negative 11. We're not talking about negative 11, so we know definitely C cannot be the answer. And this one we know this cannot be the answer either because we included negative 11. Here we're not even talking about negative 11. We're talking about positive 11, so we know that D cannot be the answer. And here we know immediately this is the answer because here we do not include 11. And that's exactly what we want. And so without even going through all of the, each of them individually, we could get an idea of which one would immediately be the answer. Okay, so better than mine. Okay, so we have plenty more time left. So let's consider the other examples or the other exercises. Okay, so let's look at this one. This one is number 2. And we have to figure out which interval correctly describes the inequality given. So which interval, all right, is it A, is it B, or is it C, correctly describes the interval that we are given? So I'm going to write it on this side so we always have it. So we have X is greater than 28. That's what we're trying to verify. So the correct answer is B. Just note that. And so what I'm going to do here is I don't want the top so we can have more space. Okay. So let's move this. And let's extend this out. Very good. Okay, so let's do it individually. So and see what each of these individually mean. All right. So we have here. Let's consider A. See what A is saying. What does A mean? Right. What is this saying? What does this all mean? Right. What is it saying? Hey, start at 28. Yeah, start at 28. And then get increasingly large and never stop. So this is saying, so let's make a note of that. This is saying, hey, that's what we want you to do. Start at 28 and continue on into positive infinity, which means we're gonna start at 28. Start at 28. Now we including 28 because we have a closed bracket. We're gonna start at 28 and continue on forever. So start at 28 and continue on forever and never stop. Again, start at 28 and continue on forever. And so if we were to draw that on a graph, how would that look? Right? How would that look? So we must start at 28. So let's draw x-axis. Let's put a 0 here. And let's say that 28 is here. So we're going to start at 28. And we're going to use the closed bracket to indicate that we are starting at 28. We're going to start at 28. Start at 28. Alright. And then we're going to continue on. We're going to continue on forever. Alright. All the way until positive infinity. So start at 28 and get increasingly large. Okay. So with that idea, what would the associated inequality be? So Alright, let's consider the numbers inside the set. Well, the numbers inside the set, they're going to be bigger than 28. So take any number inside the set, 29, 30, 40, 21. So not 21, 2021, a million. All those numbers are going to be bigger than 28. So x is definitely going to be greater than 28. That's a fact. But we must never forget that we are actually including 28. So we include 28 as well. So x is greater than or equal to 28. And so therefore, the associated inequality for this one is x is greater than or equal to 28. And clearly that's not the one that we're looking for. This is not the one. This is not the one that we're looking for. We want x is strictly greater than 28. Not just that it's greater than 28, but it's strictly greater than 28. We do not include the 28. And so just bear that in mind. Alright. Okay, so let's try C. Let's see if C would do us any good. What does C means in words? Let me consider C. What is that saying in words, right? What is that saying in words? Alright, so what is C saying in words? Alright, so let's begin. So C is saying, hey, start at 28. Start at 28, but get increasingly less and less and less and less and less. Get smaller and smaller and smaller and smaller and smaller. Now, we do not include 28 now, right? We do not include 28, but we go to the left and get increasingly smaller all the way to negative infinity. Alright, so in words, this is saying in words, if you were to put this in words, right? We want to start at 28. Now, when we say start at 28, let's put a quotation marks at this because we are not really starting at 28 because, 28 is not included. Alright, so we starting at numbers less than 28, but 28 is going to be our marker. Alright, so start at 28, and I hate to say that because we don't really start at 28. We do not include 28 inside our set. So let's not say that. Let's not say start at 28. We can say start at numbers less than 28. Alright, start at numbers less than 28 and get less and less and less. Alright, so start at numbers less than 28 and get less and less and less and less and less. Okay, so how would we represent that in graphical form? Well, what we'll do is we would go on our x-axis, right? We are going to make a good identification of 28, and we are going to say that, hey, listen, we do not include 28, we do not include 28, but we are going to get less and less and less and less and less, okay, all the way until negative infinity. We're getting smaller and smaller and smaller, okay. And so what that means, so numbers in here, right, values in here are gonna be less than 28. So say, the 0 is gonna be here, negative 1 is going to be here, and so on, right? We're getting lower and lower and lower. And so these numbers, any number inside, right, this set of numbers, any numbers here, is going to be less than 28. So x, right, is going to be any number in here is going to be less than 28, but strictly less than 28, because we do not include 28. And so let's put that there. Let's put the associated inequality there. So x, this inequality, this interval is representing the inequality. X is less than, strictly less than 28. But if we look carefully, we want x is greater than 28. We don't want less than 28. All right, we want numbers greater than 28. And so x is going to be greater than 28. All right, so that's very, very important. So x is not strictly less than 28, x is actually greater than 28. So definitely this inequality would not work. Right, so this would not work. This would not work. Okay, so let's continue on. Let's consider B. Would B work? And what is B even saying? Like, what is that saying in words? What is that saying in layman terms, right? What is that saying in everyday language, right? Alright, so what is that saying? In words. Okay. Alright. So B, what is it saying? This is saying, hey, start at 28. This time we include the 28. So start at 28, but get less and less and less. So this is basically identical to C, but this time we include the 28. So this is saying, hey, start at 28, my friend, but get less and less and less and less and less. Okay? And so here we can say by right? We can say truthfully and accurately, hey friend, start at 28 and get less and less and less. Okay, so start at 28 and get less and less and less and less. And so if we would do that, we go on the number line. All right, go on the number line, and we want to start at 28. So this time we include the 28. So we're going to use the square brackets. We include 28. We include 28. Alright. And we're going to get less and less and less and less all the way to negative infinity. Getting lower and smaller, smaller and smaller and smaller and smaller and smaller. And so how would we represent this? All the numbers that are in here are going to be less than 28. So any number, call it x, inside this set of numbers, it's going to be less than 28. Okay? But we also include 28. So there we go. So x is less than or equal to 28. Alright? And so there you have it. So the associated inequality for this one is x is going to be less than or equal to 28. Alright, so that leaves us with D. Right? That leaves us with D. Okay, so how are we going to, what is D saying, right? Now, right about now, so sorry, let's make it prominent that, hey, this is not correct. So we are left with D. And let's verify if D is this one. Because here, this is saying x is less than or equal to 28, but we want x is greater than 28. That's what we want. And clearly, we do not have it. And so, moving on along. Alright, moving on along. So let's move all this out. And so we have, so what is this saying? Okay, this is telling us, hey, start at 28, but get increasingly large. Alright, and so that's what it means in layman's terms. Start at 28, but get increasingly. Oh, no, we cannot start at 28. Notice that this does not include 28. So we're going to start at numbers bigger than 28. Alright, so, but 28 is our marker. So we're basically going to quote start at 28, but we know we don't really start at 28. Let's just put quote start at 28 just to indicate that, hey, we do not include 28. So we're going to quote start at 28 and then get increasingly large. So in layman's terms, we are saying, hey, the 28 all the way up to positive infinity. So we're going to start at numbers greater than 28 and then get increasingly large. So start at numbers greater than 28 and get increasingly bigger. So start at numbers greater than 28 and get increasingly bigger. And so if we were to graph this on a number line, we would have 28. So let's have 0 here. We have 28 here. And we do not include 28. So that means that we are going to use an open bracket. We do not include 28, but we get increasingly large all the way to positive infinity. And so this is how you have it. So we start at numbers greater than 28 and we get increasingly bigger. And so if we look at any number inside this interval, or inside this set, well, any number inside the set would be bigger than 28. So 20, 30, 31, 32, 45, all those numbers are going to be bigger than 28. So it's going to be x is strictly bigger than 28. So that's going to be the associated inequality, and we can see that directly matches what we want. And so that is the correct one, right? So x is greater than 28. That is the correct interval notation that corresponds with our inequality here. All right, so that's the correct one. So hopefully that makes sense to you. All right, and hopefully you're understanding these things. Okay, so let's move on to another one. All right. Oh, and by the way, before we move on, we could have easily identified that D was the correct answer, even without going through it in detail like how we did just now. Say, Mr. Petit, how? Excuse me. Notice that here, for this one, we included the 28, but for the answer we wanted, we do not want to include the 28. So we know A automatically is not going to be the answer. And if we look at C, well, C is you'd have to think about this one for real, because this one is not a clear identification, but this one you could kind of see it too, because we are starting at smaller numbers and getting to 28. So, or you can think of it as we starting at 28 and getting smaller. So it cannot be this, because we're trying to get bigger. This one you gotta automatically X out B, because we have a bracket here which symbolizes that we include 28, but clearly we don't include 28. So C and D you would be left with, but you know that it can't be C because you're getting smaller and smaller and smaller. But we actually want to get start at 28, or start at numbers greater than 28 and get increasingly larger. So that's why D would be a better choice, even without going through it in detail like we did just now. All right. So just bear that in mind. Okay. Moving right along. Let's consider another example. So example number 3. So let's take this. Alright, let's take this and let us place it here. And the next thing we're going to do is we're going to get the inequality. Alright, very good. Okay, great. Okay, great. So, what is this saying? This is saying x is less than or equal to -5. That's the inequality that we want. And we're trying to figure out which of these interval notation correctly tells us or correctly is associated with this inequality. Okay, so we have this one, A, we have C, we have B, and we have D. Which of them correlates or is a representation of this? Alright, so let's begin with A as usual. And what is A trying to say? Well, A is saying, hey, why don't you start at -5? Well, no, we can't really start at -5 because we have an open bracket. But start at numbers greater than -5 and get increasingly bigger. Okay, so that's what we're saying in words. Hey, listen, start at numbers. So start at numbers greater than 5. Sorry, greater than -5. And get bigger and bigger and bigger, or continue on forever, right? So start at numbers greater than 5 and continue on forever. So how would we graph that? How would we draw that graphically? Well, we have the x-axis. We have 0. We have -5. And here they're telling us, hey, listen, do not include 5. Don't include 5. Start at numbers bigger than 5 and get increasingly bigger, right? So start at -5 and get increasingly bigger. So that's the idea here. Okay. Start at -5 and get increasingly bigger. Okay. All the way to positive infinity. So that's the idea here. Start at -5 and get increasingly bigger. Okay. That's the idea that they want us to understand. Okay. All right. So let's look at these numbers in here, right? So the numbers in here, well, 0 is here. 0 is bigger than -5. Positive 5 is here. That's bigger than -5. 7 is here. That's bigger than -5. 8 is here. That's bigger than -5. And so all of these numbers, say take a number here, call it x, right? Any number in here, we call it x. That number, if it's inside the set, it's going to be strictly greater than -5, right? And so that's the inequality that we have represented by this interval. And so this is going to be x is strictly greater than -5. So x is going to be strictly greater than -5. Okay. And next up, we are going to do which one? B, C, or D? Which one should we do next? Let's do B. Let's do B next. Alright, let's do B next. Let us do B next. So let's do B. And so B, let's do B. So B is going to be less than, sorry, what B is saying? B has, open bracket, -infinity, +infinity. What this basically is saying is, hey, listen, start at 5. Well, we can't really start at 5 because it's open bracket. But start at numbers less than 5 and get less and less and less and less and less. So start at numbers less than 5 and get less and less and less. That's what it's saying. For this one, so it's saying, hey, listen, start at numbers less than 5. So start at numbers less than 5 and get what? Less and less and less. So start at numbers less than 5 and get less and less and less and less. And so what that means, we're gonna go on our line, our x-axis, and we are going to start at 5, and get increasingly less and less and less. So again, we start at 5, so that means we include 5. We include 5, and we get less and less and less and less. So start at 5 and get progressively less and less and less and less. Alright? So we start at 5 and we get less and less and less and less, all the way to -infinity. Alright, so start at 5 and get less and less and less and less. Okay, great. So if we look at any number inside this set, any number, oh, we do not include 5. Why did I include 5? We do not include 5. Let's make that correction. We do not include 5. Yeah, so do not include 5. That's a mistake on my part. Do not include 5. So here we do not include 5. So open bracket. We do not include 5. Alright? But we get progressively less and less and less and less. So we start at numbers less than 5 and get increasingly less and less and less. Small, 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 small. And so this is saying if we take any number inside this, set, let's call this number x. That number, any number in here, is going to be strictly less than 5. And so the inequality that's associated with b, okay, is going to be x is strictly less than 5. Okay, let's do C. Let's do C. Or should we do C? Or should we do D first? Let's see. Let's do D first. So let's do D. So what is D saying? What does D mean? What does that interval notation mean? What does that interval mean? What does that represent? What does that correspond to? What inequality notation, sorry, what inequality form does that correspond to? So we have, what it's saying is, hey, listen, start at 5. Sorry, start at -5. This time we include the -5. Start at -5. I dare you. Start at -5. And then get increasingly large. Okay? So start at -5. So let's make a note of that. So we're going to so here we start at -5 and we get bigger and bigger and bigger. So we start at -5 and we continue on forever and ever and ever. And so what that means, if we were to graph that on our number line, we would have the following. So we're going to start at -5. So this is 0 here. We're going to start at -5 and we're going to get increasingly larger. All right, bigger and bigger and bigger and bigger and bigger. So start at -5 and get increasingly larger. Here we do include -5, so we're going to use a square bracket to indicate that, hey, we do include -5. We're going to get increasingly bigger. So start at -5 and get increasingly larger. So start at -5 and get increasingly larger, all the way to positive infinity. And so if we look at the numbers that are in this set, or if we look at the numbers that are in this interval, these numbers are always going to be bigger than 5 or equal to 5. So take a number from this interval, call it x. Take any number from this interval, and let's represent that number as x. That number is going to be definitely going to be bigger than -5, but not merely bigger than -5. Also, it could be equal to -5. Okay, and so this means, so this, the associated inequality to this one is x is x is greater than or equal to, rather, -5. Okay, alright, so that leaves us with only one option, and that is C. Alright, and let's verify if C is the correct answer. This one cannot be the correct answer because it's saying x is greater than or equal to -5, but we want x is less than or equal to -5. So there's definitely a difference there. Okay, so C. So we need to see if this is correct, right? Alright, so let's erase this out. Let's erase it out. Alright, so let's erase it. Alright. Alright, perfect. So let's consider C. Now for C, what is happening here? Well, C tells us, hey, listen, start at -5. And we are actually including -5, but get increasingly smaller. So you want to start at -5, but you want to get increasingly smaller. Small, small, small. Small, small, small. Go all the way to -infinity. So let's do that. So we are going to, let's put it in layman terms first. Alright. So we have the interval -infinity, positive and negative infinity, sorry, to 5, to -5 rather. It's saying, hey, listen, start at -5 and get smaller and smaller and smaller. And so if we were to do this in a graphical representation, right, we would have this line, our x-axis, we would have 0 here, -5 here. Remember, we include -5. All right, we include -5. So we start at -5 and we get increasingly smaller. So we get increasingly smaller. All right, so better than mine. So start at -5 and get increasingly smaller. And so if we look at this, the numbers that are inside this set, if we take any number from this set, let's say we take a number, call it x, any number now, you know this number is definitely going to be less than 5. That's less than -5 rather. But it also could be equal to -5 right now. So numbers like, you know, -6, -7, -8, -9, -10, these are going to be less than -5, but we also include -5, so we have less than or equal to. And so definitely, so this is the associated inequality for this one, is x is less than or equal to -5. And so that means that the correct answer here is C. So C is going to be that interval notation that corresponds with this inequality. Okay, that's great. So let's continue. All right. All right, so let's continue. So for these ones, let's look at them. All right, and how much more do we have? We have 8, 10. Okay, so let's look at them and talk it through, walk it through, and use our understanding of what we know to think about it even without actually drawing it out. All right, so let's use our understanding of these things to think about it even without drawing it out. All right, so that's the idea for this one. So try number 4 on your own. So try number 4 on your own. Okay, try it out. Try number 4 on your own, and then pause the video. And so right now, pause the video. Try number 4 on your own, and then we'll continue right after. Pause it, and then right after you pause it, I'll see you after the pause. Okay, so hopefully you already tried, number 4, and you got the correct answer. So let's do it together. So let's consider number 4 together. So what does this inequality mean, right? What does this inequality mean? Well, this is saying that we have 16 is less than or equal to x. All right, so 16 is less than or equal to x So that means that, what is it saying? It's saying that x is going to be bigger than or equal to 16. So what numbers are we looking at? We're looking at numbers like 17, 18, 19, 20, 25, because these numbers are going to be bigger than 16. But 16 could also work. All right, so that's also important. So what could we immediately rule out? What could we immediately rule out and say, hey, no, you're not right and stuff like that? What could we immediately rule out and say, okay, definitely that's not right? Well, we can't really do it for none of these because, well, except for B. B is straight out wrong because we're not dealing with negative 16. We're dealing with positive 16. So definitely we know that B is not right without even going into much detail. The same is true for D. We're not dealing with negative 16, so that's not we don't even have to consider that. Now, so the options either for this one or for this one. Remember, x, the examples that we have for x, that x could be numbers like 17, 18, any number bigger than 16, okay? And so if we look at this interval notation, let's look at C first. C is saying, okay, start at 16 and get smaller and smaller and smaller and smaller. But we don't want to get smaller and smaller and smaller. We want to get bigger and bigger and bigger. So that leaves us with the only option, A. A is telling us, hey, start at 16, all right, and get increasingly bigger because we continue on into positive infinity. So the correct answer here for this one is A. All right. Okay, so that's the correct answer. Moving right along, let's look at number 5. So number 5 says x is bigger than 30. So x is strictly bigger than 30. So if we were to write that down, what numbers would we be considering? Numbers like 31, right? 40, any number bigger than 30. So what can we immediately rule out? Well, we can immediately rule out B because B is saying include 30, but we don't want to include 30. So we could immediately rule out B. We could immediately rule out D too because D is saying include 30. We do not want to include 30. Now we're left with these two. Right? We cannot immediately rule out these. We are left with these two. We could immediately rule out C because C talking about negative 30 and we are not dealing with negative 30. So this one is the correct one because we are going to start at numbers greater than 30 and then we're going to continue on into positive infinity, numbers getting bigger and bigger. So 31, 40, 45, stuff like that. So the correct one is A again. Okay, so moving right along. So number 6. Number 6. For number 6, this is saying x is strictly less than 2. So x is strictly less than 2. Okay, x is strictly less than 2. So we're dealing with numbers that are less than 2. So numbers like 1 is less than 2. 0 is less than 2. Negative 3 is less than 2. So numbers that are less than 2. Strictly less than 2. So we do not include 2. But here we include 2. So we know that this cannot be it. So A is not the answer here. Here we include 2 again. And we do not want to include 2. So we know that D is not the answer either. So it's either out of C and B. Okay, let's look at B. B is saying start at 2, but get increasingly bigger, right? We don't want to do that. We want to B is saying start at numbers greater than 2 and get increasingly bigger. We don't want to do that because we're trying to get smaller. And so the correct answer is C, because we are going to start at numbers less than 2 and get increasingly smaller. Alright, so the correct answer here is C. Alright, next up we're going to do number 7. So number 7. Alright, number 7. So number 7 tells us, let's use a different color. So number 7, we have x is greater than or equal to negative 14. X is greater than or equal to negative 14. So here we're looking at numbers that are bigger than negative 14. So any number that's bigger than negative 14. So 7 will work. 20 would work. 25 would work. Once it's bigger than negative 14. And we also could include negative 14 as well. So seeing that we include negative 14, we know immediately that this one is not going to work, because here we do not even include negative 14. The same thing is true for B, because here we in the question, in the inequality given, we include negative 14, but here we do not include negative 14, so this is definitely wrong. Let's look at C. Is either going to be C or D? We want numbers that are bigger than negative 14. Let's look at C. Here, C says, hey, start at negative 14, but get smaller and smaller and smaller and smaller and smaller. But we don't want to do that. We want to get bigger and bigger and bigger. So it's not this. So the answer is definitely D, because we're going to start at negative 14 and get increasingly larger. And so the answer here is D. All right, let's look at number 8. For number 8, we are going to the saying x is less than or equal to 27. So we're going to look at numbers that are less than or equal to 27. So you're looking at numbers like 26, all right, 14, 12, 0, okay, and so on. And so, these numbers are going to be less than, and 27 could also work too, because we include 27. So, but we want numbers that are less than 27. So, we know A cannot work. A cannot work because we do not include 27. This is open bracket. But in the question, we do include 27. So this is not going to work. For B, how about C? C we could immediately move as well, because here we're talking about negative 27. In the inequality given, we have positive 27, so that's not going to work. So it's either B or D. So B is saying we want less than 27. Numbers less than 27. Okay, let's consider D. D says start at negative 27. Alright, please forgive the background talking. I am not home alone. Very sorry about that. So negative 27, and we want to, this is saying start at negative 27 and get increasingly less. So B is the right answer. The reason why, so D is the right answer. The reason why B cannot be the right answer is because this is saying, hey, start at positive infinity. So I start at, looks like these are saying the same thing to me. Yeah, they're saying the same. No. This is negative 27. So yes, this is wrong. We're dealing with negative 27. That's not right. So yeah, so B is correct. Because here this is saying, hey, start at negative infinity and get increasingly big and stop at 27. Or you could think of it as saying, start at 27 and get smaller and smaller. So B is definitely the correct answer in this case. Alright, so we have 2 more to go. And for these two, we're going to take our time and do them. Alright, so we're going to take our time and do these last 2. And that should be it for math after we are done with these. So we'll see how that works. So we're going to explain these ones thoroughly, or with much more detail than we did the other ones that we did recently. So let's do number 9 and number 10. And then I will be out of your way for the math section. Alright, so let's continue. So this is saying we want 9 is greater than or equal to x. So let's begin with A. What is A saying in words, in layman's terms? Well, A is saying, hey, listen, start at 9, but then get increasingly smaller. Alright, so let's put that up here. So it's saying, hey, start at 9. So start at 9 and get smaller and smaller. So start at 9 and get smaller and smaller and smaller. That's what A is saying. So how would we represent that on a number line? So we want to start at positive 9 and we want to get increasingly smaller. Remember that we are going to start at positive 9. So start at positive 9 and we're going to get increasingly smaller. Alright, so all the way to negative infinity. So start at positive 9 and get increasingly small all the way to negative infinity. So if we consider the numbers that are going to be inside the set, these numbers, take any arbitrary number that you can think of in the set, call it x. That number is going to be less than or equal to 9. Alright, and so the associated inequality for A is definitely x is less than or equal to 9. But that's not what we want. Hey, we want, you have to be careful. This is saying that 9 is greater than or equal to x, or x is less than or equal to 9. So we immediately found it, because think about it. If you have to really think about it, if 9 is greater than or equal to x, then that means that x is less than or equal to 9. These inequalities are saying the same thing. Okay? And the reason why that's true is because think about it. 9 is greater than or equal to x. If you look at any number in the set, 9 is going to be bigger than it. So 9 is bigger than, if we add 8 here, if we add 7, if we add 6, 5, and so on. 9 is going to be bigger than all these numbers, and 9 is bigger than everything inside the set. Alright? Or equal to 9 itself. So the correct answer is actually A. Okay, immediately, straight out. We found that that's the answer. I was not expecting that to be the answer, but it turned out to be the answer. Alright? So A is the answer for this one. So with that being said, let's move on to the other one. But before we do that, notice that the other ones could not work, because this is saying do not include 9, and this is but here we want to include 9, so we cannot use that one. Here this is saying do not include 9 as well, but we want to include 9, so this does not work. Here this is saying include 9 but get increasingly bigger. But no, we don't want to get it bigger because that means that x would be greater than 9. But we want 9 to be greater than x, so this cannot work. And so the correct answer here is definitely A. And so now we move on to our last question for tonight as it relates to math. So the last question is this one. Number 10, which one corresponds? So let's put this here. And let's consider this inequality. Alright, good. So here we have, sorry, let's increase this. And so here we have x is strictly greater than negative 20. Again, x is strictly greater than negative 20. And so what does that mean? That means, okay, we want all the numbers that are bigger than negative 20. So 50, 55, 2000, 1 million, all these numbers are bigger than negative 20. And so they are going to be the ones that we'll be considering. And so with that being said, let's consider each of these inequalities and see which one is the correct one. So let's look at this one. Let's look at A. Well, this is saying, hey, listen, this is saying start at negative 20. It's saying start at negative 20, because we have the square bracket, so it's saying start at negative 20. So start at negative 20 and continue on until, and continue on forever, basically. And continue on forever. So start at negative 20 and continue on forever. So that's what this is saying. Start at negative 20 and continue on forever. So that's what this is saying. And so we're going to start at negative 20 and continue on forever. So let's just draw that graphically. How would that look? So on a graph, we have 0, we have negative 20. We are going to start at negative 20. That means that we include negative 20. And then we're going to continue on forever and ever and ever. Alright? So we start at negative 20 and we continue on forever and ever and ever. That's what that's saying. So if we look at any number inside this set, right? If you look at any number inside this set, let's call that number x. This number would have to be greater than negative 20 or even equal to negative 20. Alright? It have to be greater than negative 20. So we look at numbers like 2000, 500, stuff like that. They are bigger than negative 20. But this is not what we want. It's close, but it's not what we want because we do not include the 20. This is x is greater than or equal to negative 20. Sorry, we do not include the negative 20. And so, no, this is not correct. So this one is not right simply because we included the negative 20 when we were not supposed to include that. Alright, let's look at B. Alright, let's look at B. Now the problem with B, we're running out of time. We're basically out of time in a sense for math, but just to do it quickly, B is not going to work because here we're dealing with negative 20, but for B we wanted but for B we have positive infinity. So this is not going to work. This one, sorry, let's look at D. D is not going to work because we're looking at positive 20, and here we want negative 20. Alright? Alright, so this is not going to be right. Um, and so if we look at alright, so if we consider C, C is definitely correct, because C tells us, hey, listen, start at negative infinity, but no, not really start at negative infinity because I'm sorry. C tells us that we start at numbers greater than negative 20, and we continue on to positive infinity. Again, we start at numbers greater than negative 20, and we continue on into positive infinity. Alright? So again, we start at numbers greater than negative 20, and we continue on into positive infinity. So that means that x is going to be strictly greater than negative 20. Alright? X is strictly greater than negative 20. Alright, so that brings us to the end of math. So the correct answer here is C. Again, for this one, we start at numbers greater than negative 20 and we continue on to positive infinity. So that means that any number inside this interval is going to be bigger than negative 20. So we start at numbers greater than negative 20. We continue on into positive infinity. Any number in here is going to be greater than negative 20. Alright, so that brings us to the end of this lesson for math. Now let's move on and let's do the history or social studies. Alright. Alright, so let's do our history. So we're going to history or social studies. Alright, so the topic for today. Alright, so the topic for today is the Arawaks, and we're gonna be talking about how they live. Now we touched on this. We touched on this sometime. We touched on this the last time we did social studies. But we're gonna do it. We're gonna continue right on talking about how they live. Specifically today, talking about how did they get their food and the things that they use to get their food. Now, when it comes to social studies, my disclaimer is I am giving you information, not facts, not necessarily facts. So better than mine, I'm gonna give you information that you need that you're gonna need for your exam, right? But do not consider anything I give you as fact. Consider it only as information that you need for your exam. The only thing that you consider fact is something that you have studied, you have done your research on, and you have come to your own conclusions and stuff like that. These are just information that I give you as a teacher to help you with preparing for an exam. Alright? Okay, so let's begin. So let's continue. So let's continue with our notes. This is saying so let's discuss it. We talked about last time about the houses, we talked about the houses that the Leukaems had. We talked about their houses. talked about how the cacique had, or the leader had, a bigger house, how that his house was bigger and rectangular. We talked about how their houses was, round, with a canonical roof, with a cone roof. We talk about how that their cooking and eating were done outside, and um, and that they did their field work, they did their agriculture in the field. Now today we're going to be talking about how they lived, and how did they get their food, and some more details concerning that. So the Leukaeans, right, based on according to this information, they are telling us that the Leukaeans lived in a communal environment, or communal cooperative rather, right? Communal cooperative way. Right? So they 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 had a togetherness, a cooperative, friendly spirit. All right. They had a so Lucans lived a communal cooperative way of life. All right. That's one thing about the Lucans. They were friendly, they were cooperative and stuff. They also lived, right? They also lived at a subsistence level. And what does that mean when we say subsistence? That means that, meaning they only grew enough. They only grew enough food for their own needs, right? For their own needs, right? So the Lucayans, they had a subsistence. They were not commercial, right? Commercial means that we grow enough for us and we grow enough for everyone else. But subsistence means, hey, I'm only gonna grow enough for me, and I'm gonna grow enough for me and my own needs. So that's what subsistence means. So the Lucayans were more subsistence than commercial. All right. They did not, right? They did not trade food with others. All right. They did not trade food with others, but they did trade other items, right? But they did trade other items, such as gold pieces, right? Special stones, axe heads, and pottery. So even though they did not trade food, right? They did trade other things, okay, like gold pieces, special stones, axe heads, and pottery. So the clients, they live a communal way and cooperative way of life. They have a subsistence level, not commercial, not like a big enterprise where they ship into North America, ship into South America, all those stuff. No, they grow enough for their own needs. They grow enough food for their own needs. They don't trade food, but they trade other items like gold, special stones, axe, pottery, those stuff, right? Um, so let's look at their ways of getting food. So we're gonna break this down. We are going to need we're going to need 4 headings, and we're going to um, place let's say we have let's say that we have let's use 2 columns for now. Oh, sorry, or not 2 columns, 2 rows for now. So we're going to talk about, let's bring this down. So let's bring this down. So we're going to talk about, sorry. We're going to talk about four ways of getting their food. So 4 ways of getting their food. So how did the Leukaeans get their food? The first way that we can talk about is fishing. Alright, so fishing is one way that they get their food. So obviously they would eat things from the water. The next way is farming. And so they would farm, they would do agriculture. And the next way is hunting. And the third way is gathering. Alright. So the Leukaeans get their food by fishing, farming, hunting, and gathering. Alright. Alright. So what did they fish for? Well, the most obvious, they fished for fish. They fished for turtles. And they fished for seals. Okay. They fished for fish, turtles, and seals. That's Leukaeans. They would fish for fishes, turtles, and seals. And now for farming, right? For farming, what would they farm for? They would grow cassava, right? They would grow maize, and maize is just a fancy name for corn. Sweet potato, they would grow sweet potato, right? Sweet potatoes, to be more precise. Peppers, okay, and herbs, right? And tobacco, and the tobacco was used for religious services too. Tobacco and cotton, okay. So these are the food that they would eat. Notice that they're from the ground, all right. Now, how is that in contrast to the things that we eat today? I mean, certainly we do eat cassava. If we look at the Bahamian diet, we do have cassava and sweet potatoes. We do have corn, we do have corn, peppers. But a lot of our stuff are imported. So we do a lot of importing of things. They grew most of their stuff, right? And they, or I just say they did more growing than us, certainly. And so that's a difference. We do less growing than them. We do a lot of importing, as in the Bahamas, we do a lot of importing. And so we would import the lettuce, we would import the the um the kale, we would import the sweet potato, the peppers, and the sweet potatoes. Okay, now there are some, places where we could where they do grow this in the Bahamas, but it's on a small level, not really a grand scale. Now hunting, so they have the herbs and things on the ground, but they also had some meat in their diet from the fishes and the turtles and the seals. Also from hunting too, they also had meat in their diet. So they used to eat the iguana. So they would hunt for the iguana, the conies, and gutias, right? Then agoutis, agoutis, and snakes. All right, so these would be a part of their diet. Now, this for us, we don't typically. The Bahamian diet doesn't typically consist of snakes, certainly not, and iguanas. No, we eat more of the chicken, the turkey, the beef and the pork and those sort of stuff. All right, and so let's move on to gathering. Now, what did they gather? They gathered shellfish, they gather eggs, they gather berries, and they gather fruit. All right. So these are their 4 ways of getting food: fishing, farming, hunting, and gathering. And the things that they used to fish for was fish, turtles, and seals. As for farming, they used to farm for cassava, maize. They used to grow sweet potatoes, peppers and herbs, and tobacco and cotton. As far as hunting goes, and the meat that's associated with their diet, it would be iguana, conies, gutias, agoutis, and snakes. And as for gathering, it will be shellfish, eggs, berries, and fruit. Now, how would they do this? Like, how would they use? What are the instruments that they would use for, you know, gathering these or getting these things or performing these tasks. So for fishing, right, they would use nets. So obviously their technologies are going to be more primitive and more simple than ours than we do today, right? But it still got the job done, at least in terms of them, and so they used it. And so they use nets, they use hook and line, and they use remora. Next up, in terms of instruments for farming, right? Instruments, or in this one, more so techniques, right? Instruments or techniques. So they would use the slash and burn method as a type of farming technique, right? So they use the slash and burn method in farming. To get good yields, and that involve burning the soil and stuff like that. They also use a digging stick, so a digging stick, which is called a koa. All right. In terms of instruments that they use for hunting, definitely traps, spears, bows and arrows, and clubs. So these are the instruments that they use for hunting. And as far as gathering goes, that would be done by hand or using baskets. Okay. So there are 4 ways of getting food, and we also have the ways that they got it and how did they do it. They use nets and hook and line and remora for fishing. They use a slash and burn method and also a digging stick for farming. For hunting, they use traps, spears, bows and arrows, and clubs in order to capture these creatures. And for the gathering that they did it by hand or using baskets. All right. Okay, so let's continue with the rest of our discussion. Okay, so continue on talking about the AWACS. So we can see, right? What can we see? We can see that the Leukaeans had a balanced and diverse diet. The reason why we say balance in terms of this definition is that they have food coming from all food groups. So they have the fish, they have the stuff from the ground, they have meat, and they even have the berries and the fruits and stuff like that. So we describe it as a balanced diet and a diverse diet because it's not one where we have food from one specific food group. Okay. A favorite dish. Favorite dish of the Leukaeans was the pepper pot. Now, what was the pepper pot? This was a stew, right? So the pepper pot was a stew of meat, and vegetables that was cooked slowly over a fire. Alright. They also made cassava cakes. Right, so they also made cassava cakes on pot girdles. Okay. Alright, so continuing on. So we can describe more of these sort of stuff. Still talking about their way of life, just describing it more and more. So Leukaeans achieve this balance. Alright, Leukaeans achieved this balance. How did they achieve this balance? This balance of diet and it being diverse and stuff. How do they do it? By what? By mixing what? Farming, hunting, that we talked about earlier. So they farmed. So not only did they farm, but they also what? They also hunted. With farming, by mixing farming with what? Hunting and fishing. So that's how they achieved the diversity that they got. Because they farmed, they hunted, and they also gathered too. Alright, and they fished. So that's how they achieved the balance. So iguanas would be hunted by tormenting them, right? Until they showed their teeth, right? Until they showed their teeth. So we explaining how they hunted for the iguana. Then stuffing something into their mouths, right? And tying them up. So that's the trick. So they would torment these creatures until they show their teeth, and then they would quickly stuff something inside their mouths, and then they would tie them up. Shifting cultivation. So this is talking about how did they, do the farming aspect. Shifting cultivation of farmland would provide vegetables, right? Would provide vegetables, an area of bush was cleared, then tree stumps rather, were removed. How do you think they're gonna remove the tree stumps? Well, guess what? They remove it by burning, right? But the remaining soil, they're gonna use that to plant crops. So the remaining soil was planted with crops. And we talk about some of the crops already, such as cassava, sweet potatoes, maize, which is corn, and cotton. Now, what's gonna happen as time and time progress, right? As time and time progress, the soil that they have is going to become infertile, and so what they do is that they would move on to another area. Okay, so within a couple of years, the soil would become infertile, and another patch of bush would be needed and they would what? Clear it for use. Okay. Now, in the Leukaem community, men and women had different roles. All right. So men did certain things, and women did certain things. And so we're going to talk about the roles of men and women in the Leukaem community, and then we're going to wrap it. So men and women also carried out different roles. Okay. This is illustrated in the table below. So, alright, so let's talk about the different roles of men and women in the Leukaem community. So you only need 2 rows and 2 columns for this. So on one side we have men, and on the other side we have women. So the men's responsibility was to clear fields. Right, this is what men did. They cleared fields, they hunted, they fished, they made canoes, and they trained the boys. Now as far as the women, they planted crops, they looked after crops, they cleaned the houses, they prepared food, they made pots, baskets, and clothing. Clothing, hammocks, and zemis, that's the gods or the idols, and then they brought up the children. Okay, so here we have the roles of men and women, and the men did the activities that were more outdoors and more fast paced and um, more strenuous in the sense of like the hunting and the fishing and the making of canoes and clearing fields. The women would do more indoor activities, stuff like cleaning the houses, preparing the food, making clothes, making sure that the clothes are made, and making sure that the hammocks are made, and then raising up the children. All right. And so that brings us to the end of our social studies discussion. All right. So we're gonna end it off with, and hopefully you learned some more information about the Arawaks and the Leukaeans, and how they lived and how they did what they did, how they carried their way of life, what they ate, how they got it, and those sort of things. Okay, so now we're gonna move on. All right, now we're gonna move on, and we're going to talk about we're gonna move on to RK, religious studies. Okay, and our topic for religious studies, we're gonna continue on with the with the with the Magi's, or what people will call the wise men. Okay, the Magi's or the wise men. All right. All right. So this is this is by the way, this heading is wrong. It's supposed to be January 20th, and so still Thursday. Okay, so Thursday, January 20th. Here we're gonna look at the subject is religious studies, and we're going to be talking about the wise men. Now, this is part 2, because we started looking at this before, but we didn't finish it. Here I'm going to give you some more information that I did not include in the first part, in part 1. So we're going to give you some recap and give a whole lot more detail that we didn't really talk about in part 1. So we're going to start off with the verse, and the verse says that now when Jesus was born in Bethlehem. So this is a literal verse that comes right from the Bible. It says, now when Jesus was born in Bethlehem. I spelled that wrong. Now when Jesus was born in Bethlehem of Judea. So that was Jesus born in Bethlehem. Okay. Now when Jesus was born in Bethlehem of Judea in the days of Herod the king, behold, there came wise men from the east to Jerusalem, saying, where is he that is born King of the Jews? For we have, and this is a question, for we, this is the wise men speaking. They're saying, for we have seen his star in the east, and we are come to worship him. This is a direct quote from scripture. Alright. And if we look carefully, notice that, sorry, let me connect to the internet here. One moment, let's connect to the internet. So that's the wise men. That's a biblical account of the wise men. Now, where in the Bible would we find that particular verse? Remember, I told you that that verse comes directly from a biblical passage. All right, and that's taken from Matthew chapter 2. So let's read that. So Matthew chapter 2. Let's read. Let's go into the. Let's look at the King James version of it. It's Matthew chapter 2. So Matthew chapter 2, beginning at verse 1, it says, now when Jesus was born in Bethlehem of Judea in the days of Herod, behold, there came wise men from the east to Jerusalem, saying, where is he that is born King of the Jews? For we have seen his star in the east, and are come to worship him. So this is Matthew chapter 2, verse 1. Matthew chapter 2, verse 1 and 2. And this entire, scripture reference that we're going to be basically considering, all right, you can find it in Matthew chapter 2 itself. Matthew chapter 2. So this is a good place to start off with this, with this context. So this tells us a lot. Jesus was born in Bethlehem, and Herod was the person in charge at that time. And we had some wise men. They didn't tell us how much wise men. They're saying it had wise men from the east, right? And they literally came to Jerusalem, right? And they came with a question. They came searching. They're saying, hey, this star that we see a star. This star is representative of something, right? It's representing that, hey, a king is born. And we have seen the star. We've seen the star in the east, and we know that the star is indicative of the fact that the king is born. A king is born. And there's not any king. The king of the Jews is born. And we've seen the star, and we are come to worship this king that is born. And so they came with this question. They came searching. All right. So who was the wise men? Just some more information on the wise men. So the wise men from the east were philosophers. So they were philosophers. Now sorry, I spelled this wrong. Now they came from a larger group though. So these wise men came who traveled to Jerusalem came from a larger group, right? So they belonged, right, to a large group, to a large and influential, right, class or group of people, right, or group of people um, that included men of noble birth. Okay, so we're not just talking about we're not just talking about people. We're not talking about people who, ordinary people, the run off the mill off the street. No, no, no. We're talking about the wise men from the east. These were philosophers. They came from a large group, right? So they belong to a large group consisting of people who are very influential, and they were men of responsibility and noble birth, right? So not no ordinary people, okay? And comprised, right? And they were not poor people, right? And comprised much of the wealth and learning, right, of their nation. All right, so these were the people who are the top tier, right, of the place where they live. They are the people who had a lot of the money and a lot of the insight, right? And they were studying, and they're following up, and they're saying, listen, we've seen the star, right? We did our studies looking, because remember, they were not only rich, but they were also wise. And so that's another thing to consider. And so they're following up, doing their research, and they notice something interesting, and they come to Jerusalem to see what's up. So among these were many, right, many who imposed on the credulity of people. Sorry, let's spell that correctly. Credulity. So credulity is spelled CREDULITY. Credulity of people. Now, when we say credulity, what do we mean? Think about it. When we say credulity, what do we mean? What are some synonyms of credulity? Gullibility, naiveness, imprudeness, right? If we continue on with credulity, credulity just to state when someone is gullible. So these wise men came from a large group of people who were smart and rich. Now, some of these wise men, some of them who were part of the larger group, they were men who took advantage of people who were not as smart as them, people who's not as rich as them, right? That's one part of the group, the larger group that consisted of the wise men. But there were another part of the wise men, right? Who were people who were more upright, they were more noble, they were more men of integrity, stuff like that. So others, right? So others were upright men, right? Upright men who studied, right? Who studied the indications of providence in nature. So these were men who studied nature. They were upright, so they were the more honest ones. They were the more noble ones. You had, this entire sect of, wise men from the east, who were philosophers and rich people and smart people. Some of them were, unrighteous and bad, and others of them were upright and men who were more studious and men who looked at, what God has done in nature and what God has done in the stars and the heavens, right? So these are upright men who studied the indications of providence in nature and right and were honored, right, for their what? For their integrity and wisdom. Sorry, spelled integrity wrong. And wisdom. Of this character, of this character were the wise men who came to Jesus. So remember, what we're basically trying to say is that the wise men who came to Jesus, they were actually a part of a larger group. That larger group consisted of bad people and good people. But all of them were rich, and all of them were at the top of their line when it comes to, intellectual stuff and smartness and stuff. Some of them used their smartness for bad, and others used their smartness for good. And the ones who came to Jesus were the ones who used their smartness and their wealth for the good. Okay? Alright, so moving on. The wise man had seen a mysterious light in the heavens. Alright? Upon that night, when the glory of God flooded, the glory of God flooded the hills of Bethlehem. So they're looking and they saw a mysterious light. Alright? And obviously, if you're looking and you see a mysterious light, you would be amazed. And not only that, but it was also prophesied too, right? In the Bible as well, about the star having a great significance, right? So as the light faded, a luminous star appeared. Now, many persons think it is a star, right? And lingered in the sky, right? We should note that more information on the star is that it was not a fixed star, right? It was not a fixed star, nor a planet. But what it actually was, um, what actually was, And we're going to talk about what it actually was. It was not a fixed star, nor a planet. And that really intrigued the wise men. They was like, wow, this is something amazing, right? And the phenomenon, right? This star, this mysterious light, this luminous star that appeared and lingered in the sky, which was not a fixed star and not a planet. This we're gonna call it a star. This star excited them, right? And looking at that really intrigued them, right? So, and the phenomenon excited the keenest interest. All right. Now, this star, or that star, was a distant company. That star was a distant company. That star was a distant company of shining angels. All right, that star was a distant company of shining angels. But of this, the wise men were ignorant. What does that mean? So the star actually, what it really was a distant company of shining angels, right? That's what it really was. All right. But the wise men didn't know that, right? All they saw was what looked like a star, and it surely did look like a star. But because it was so far in the sky, and human vision is only so much, they didn't really know that if we could zoom close enough and close enough and close enough, what they really would have seen was a distant company of shining angels, right? So a group of shining angels, all right? And that also goes to show that, when it came to Christ's birth, like all heaven was interested in the birth of Christ. And it would make sense because, this is the birth of the Son of God, right? And the angels, they was excited. Heaven was excited. And of course, the angels had an integral role in this as well. So the angels was there and they showed their presence, and that shone like a star. It glowed like a star, but it was not a fixed star, nor was it a planet. It was actually a distant company of shining angels. But the wise men were ignorant of this. They did not know. They were not aware of this. But even though they was not aware that this was a distant company of shining angels, that this star that they saw was actually a distant company of shining angels, even though they was not fully aware of that yet, right? Yet they were impressed, right? Yet they were impressed that the star was of special importance, right? Was a special import to them. So even though they did not know exactly what the star was, right? And even though they did not know that it was a distinct company of shining angels, even though they did not know the specifics of it, the star that appeared, it really excited their interest. They really wanted to figure out, like, what is this? Like, what is this star all about? And of course, as philosophers and, as persons, as researchers, what they did is that they started to search and look, trying to figure out what is the star, what is the star, what is the star, right? So they consulted priests and philosophers, right? They consulted priests and philosophers and searched out the scrolls of the ancient records, right? Now, the Bible had already said, or already prophesied about the star coming to be, and they saw the prophecy. So what did they find when they searched the records, right? The prophecy, that's all the way back from an old time, Old Testament prophet named Balaam. So the prophecy of Balaam, right, had declared, and here it is coming from, let's get it. It's found in Numbers chapter 24, verse 17. All right, Numbers chapter 24, verse 17. Let's go to Bible Hub. I like Bible Hub. It gives you the different translations as well. Let's read the NIV. It says, I see him, but now I behold him, but not near. A what? A star will come out of Jacob. A scepter will rise out of Israel. He will crush the foreheads of Moab and the skulls of the people Sheth. Right? That's how one version reads it. Notice how the King James Version renders it. It says, I shall see him, but not now. I shall behold him, but not nigh. There shall come out a star out of Jacob, and a scepter shall rise out of Israel, and shall smite the corners of Moab, and destroy the children of Sheth. And so this is very important, because this is telling us exactly, this is a prophecy, right, of the birth of Christ. And it's comparing Christ to a star, right? It says a star shall come out of Jacob, right? Like we're gonna see him, right? We're gonna see him, but we're not gonna see him now. We're gonna behold him, but he will not be near, right? A star is gonna come out of Jacob, and a scepter shall rise out of Israel. So that scepter refers to the kingship, right? I mean, who has a scepter? A king has a scepter, right? And so this is a prophecy from Balaam. And this is what the wise men saw. And they said, oh, this star is representing the fact that, hey, listen, a king is born, right? A king, the king of the Jews, or the king of Israel, right? And so that's how they, and so using this prophecy, they was able to put the pieces of the puzzle together. Say, hey, okay, a star coming out of Jacob. Oh, so the star that we see actually represents the Messiah, all right? And so that's how they were able to piece it together. And so let's begin. So the prophecy of Balaam had declared, let's put it in. Let's put it in properly. Let's see. I shall see him, but not now. And let's put that in red. All right, that's good. I shall see him, but not now. I shall behold him, but not nigh. There shall a star out of Jacob. Right, so we can highlight that part. There shall come a star out of Jacob, and a scepter. A scepter, that's the indication that Christ would be the king of Israel. And a scepter shall rise out of Israel, and there shall smite the corners of Moab, and destroy all the children of Seth. Okay, and so that's Numbers chapter 24, verse 17. And so could this, right, so the question arises, right, could this strange star that we're seeing, right, could this strange star, right, have been sent, right, as a harbinger, right, harbinger of the promised one? And when we say harbinger, all we mean is a signal or an indication, right? Harbinger. So If we look at the synonyms, notice it says a forerunner, a herald, an indication. Alright? So could this star, could this strange star be an indication of the promised one? So they're putting one and one together, so they see the star. They don't know what it's actually, that it's actually a company of distant angels, but it appears to them as a star. They see it. They don't really know what it means or what it represents, and so they search. They ask the priests. They ask the philosophers, saying, "What does this star represent? What is this?" They found a prophecy in Numbers, and they're talking about a star, right? And a star being an indication of a king, all right? And so they're trying to say, okay, well, could this star be an indication of the promised one? Okay? So the Magi, or the wise men, the Magi, had welcomed the light sent from, the light of heaven. The Magi had welcomed the light of heaven, sent truth. Now it was shed upon them in brighter rays. Okay? Through dreams, they were instructed to go in search of the newborn prince. And so the reason why they went is not only because of the fact that they saw the prophecy and they were inquisitive, but also they were given indications by the providence of God through dreams that they must go and search for this prince. And so that added their unction to, hey, let's go and figure it out. Let's go and see, what's this all about? Let's go and see, um, let's go and see, you know, um, let's go and see if we can find the Messiah. All right. And so they were instructed through dreams. So the star that they saw actually represented the fact that represented indicated the birth of Jesus. And they came to Jerusalem with this question: where is he that's born King of the Jews? For we have seen the star and we have come to worship him. If we continue on with Matthew chapter 2, if we were to continue on there, let's continue on, finish and read some more before we, close the study. Still have a few more moments left. It says, so they came to Herod with this question, where is he that's born King of the Jews? And you need to understand that Herod, he was a man in power, and he's actually a king himself, Herod the king. So when he hear these wise men talking about, hey, where is he that's born King of the Jews? As a king himself, he is, feeling anxious, he is feeling threatened, threatened by a baby, right? Interesting, right? But threatened nonetheless. He felt threatened, and he's like, who is this king? I am the only king. I mean, of course, he didn't tell that to the wise men, but of course, he's kept his self reserved so that they wouldn't know. But he's like, okay, what king you talking about? So it says, and when Herod heard these things, he was troubled, and all Jerusalem with him. And when he had gathered all the chief priests and scribes of the people together, he demanded of them where Christ should be born. So the wise men came to Herod, and Herod is troubled. Herod don't know, what is up and stuff like that. And so Herod goes to the chief priest and says, listen, y'all need to speak up. What is this all about? where's Christ going to be born? Where's this King of the Jews going to be born? And they said, listen, we know where the Messiah is going to be born. And of course they knew. They said, listen, there's a prophecy which tells us that he's going to be born in Bethlehem. All right. And so we're going to end right there. We're going to pause right there and continue the story some more further. But hopefully you got some information and you learned a whole lot from this study. So thank you for watching, and I'll see you on Monday. Make sure please take good notes and send them to me once you are done.